Okay, in the last video I introduced the idea of confidence intervals. We're creating a interval of numbers where we think the population proportion lies between. We're in section 9.1 here, and let's take a look at problem 3. So in 2011, there was a survey that was conducted where 3,515 of 3,995 women aged 18 to 40 in the following countries listed who had a child in 2009 to 2011 indicated having breastfed the baby. Okay, now what would it look like if we were to survey all women in this age group in the world who had a child in the years 2009 to 2011 and indicated that they breastfed the baby? Okay, like what percentage would that be? Well, part A, obtain a point estimate for the proportion of all women age 18 to 40 who had a child in 2009 to 2011 and breastfed the baby. So we want to take x divided by n. X is the number of individuals that have this characteristic, which from the sample is 3,515 said that they breastfed the baby. Okay, 3,994 participated in the study. That would be n. And when you divide those numbers, we get 0.88, or roughly 88% of the sample indicated that they breastfed the baby during those 3 years there. Okay, now if we were to survey the entire population here, that is all women aged 18 to 40 who had a child in the years 2009 to 2011, I don't think it would be exactly 88% who would say that they breastfed the baby. Now, ideally, it would be, hopefully around that number based on this sample, but, we're going to try to create an interval of numbers where we think the true proportion is going to lie. Now, before we do that, we need to verify that the requirements for constructing this confidence interval about the true proportion are satisfied. So there's two conditions here. Condition 1 is where you take n times p hat times 1 minus p hat. That has to be a number that is greater than or equal to 10. And then also the sample size must be no more than 5% of the population size. So let's verify that. Well, n is 3,994. I'm going to multiply that by p hat, which is 0.88, times 1 minus p hat. 1 minus 0.88 is 0.12. When you multiply those numbers, you get roughly 421.8. That number, of course, is bigger than 10. Okay, so the sample is big enough to create this interval. Now, we want to make sure that the sample is not too big. Okay, the sample is less than 5% of the population size. We're not actually given the population size, but it's clearly large. Okay, we're looking at all women aged 18 to 40 who had a child during these years. Now, in just 2011 alone, in the United States, there were almost 4 million births. Okay, so 3,994 is much less than 5% of millions and millions. Okay, this was only the United States. Of course, we're looking at all the countries now in the world. Okay, so the sample is of course not too big. Okay. Now in part C, we're going to use the calculator to construct a 90% confidence interval for the proportion of all women aged 18 to 40 who had a child in 2009 to 2011 and breastfed the baby, and then we'll interpret what that means. Okay, so I'm going to show you how to do this on the 83, 84 model and then also on the Inspire model. What you're going to do is you'll hit Stat and then go over to Tests, and then we're going to want to scroll down here to where it says I need, let's see, 1 prop z int. So that's option A there, 1 prop z int. And you'll enter x, n, and then the confidence level. X for this problem is what, 3,515. N is 3,994. The confidence level that we're working with here is a 90% confidence level. Okay, so you'll enter that in a decimal form. It can be 0.9 there, and then hit calculate. All right, so it gives you this interval of numbers, and if you go nearest 3 digits, the lower bound is 0.872, the upper bound is 0.889. Okay. Of course, pay attention to the rounding there. That would be in the indicated on My Math Lab. Now, if you're using the Inspire model, here's how this is going to go. It's going to be kind of similar. You'll hit calculate, and then we're going to hit menu and go down to statistics, and then you'll see option 6 is where it says confidence intervals. I'm going to want 1 prop Z interval, and hit enter. You'll need to also enter in X, N, and then the confidence level. Okay, so X was 3,515. N was 3,994. The confidence level is 90%, so again, make sure that's in decimal form there. And it'll give you the, it kind of gives you the results a little different here, not in interval notation, but so the C lower means that you're talking about the lower bound, that's 0.872, and then the upper bound is 0.889. Okay. Interpret the interval. Okay, so here's my answer, this interval of numbers, and the interpretation would be to say that we are 90% confident that the proportion of all women aged 18 to 40 who had a child in the years 2009 to 2011 and breastfed the baby is between 87.2% and 88.9%, or you can give it in decimal form there. Okay, like we're 90% sure of that. Now, as in any other interpretation question, you'd want to be specific, indicate obviously indicate the gender, indicate the age group. Okay, lots of other women not in this age group had a baby, and we're not looking at those individuals. Indicate the years that we're interested in. Okay, be specific is the point. Okay, part D, use the calculator to construct a 99% confidence interval for the proportion of all women aged 18 to 40 who had a child in 2009 to 2011 and breastfed the baby. Okay, so same deal, just a different confidence level. So if I go back to the 83-84 model here, I'll hit stat, go over to tests, go down to 1 prop Z int. I think that's option A there on my screen. Hit enter. Okay, everything's going to stay the same, only the confidence level is now going to be at a 99% level. Hit calculate, and you get a new interval there, 0.867 and 0.893 if you go nearest 3 digits on both of those. So that would be my answer, this interval of numbers. The interpretation would be to say that we are 99% confident that the proportion of all women aged 18 to 40 who had a child in the years 2009 to 2011 and breastfed the baby is somewhere between 0.897 and 0.893, okay, based on this one study that was done. Now, in part E, it says, what effect of increasing the level of confidence on the what is the effect of increasing the level of confidence on the width of the interval? Okay, so I've went from a 90% confidence level to a 99% confidence level. Like, how did that change things? Well, this interval here in part D is wider than the interval that is in part C. Okay, so the width increases. In other words, the margin of error was bigger. Okay, the margin of error is the thing that determines how big the interval is. And we have a bigger margin of error in part D, and I think that should make sense to us. You see, if we're going to increase our percent confidence level and we have no new information, we're being more risky. Okay, like there's more of a chance at making a mistake, and so the margin of error is going to increase. Now, having additional information is different, okay, but in general, increasing the confidence level with no additional information means that you're going to be increasing the margin of error, so the interval is going to get bigger. Let's take a look at another one here. Problem 4. A CBS poll found that 329 of 763 adults said that they would travel to outer space in their lifetime if given the chance. Okay, in part A, we're going to obtain a point estimate for the proportion of all adults who would travel to outer space in their lifetime if given the chance. Well, in other words, I'm just simply finding the percentage of the sample that say that they would do this. 329 said that they would out of the 763 that participated, so roughly 43.1% said that they would travel to outer space if given the chance. Okay. Now, of course, the bigger question is, what if we were to survey all adults in the world and ask them this question? Okay. Would it be, around this number or not? Like, we're going to find an interval of numbers where we think that true percentage is going to lie between. Before we compute the interval, we're going to verify that the requirements for constructing a confidence interval for p are satisfied. So the first thing, we need to check that n times p hat times 1 minus p hat is greater than or equal to 10, and it is here. Okay, so the sample is big enough, and also the sample is less than 5% of the population size. Now again, the population is not known here. We don't have they're not telling us the population size, but it is clearly large. You're looking at all adults in the world. There are billions of adults in the world, and 763 is much less than 5% of billions. Okay, so the sample is not too big. All right, part C, and by the way, of course, if either one of these does not happen, then creating this interval would be a waste of time. Okay, it's not a meaningful result then because your initial conditions were not satisfied. So be sure that you're careful about that. Part C, use your calculator to construct a 92% confidence interval for the proportion of all adults who would travel to outer space in their lifetime if given the chance. All right, let's go to the calculator, and I'm going to go to Stat, go to Tests, and go down to 1 prop z int. The sample size here is 763, x is 329. The confidence level, we're working with a 92% level, so C would be 0.92. Hit calculate. Whoops, I mistyped something. Let me check that again. Whoops, I had these switched. Okay, so 329 would be x, n is 763, and that should fix it. And here's my interval. Okay, and I've gone to nearest 4 digits there on both of those. The interpretation, we are 92% confident that the proportion of all adults who would travel to outer space in their lifetime if given the chance is between 39.98% and 46.26%. Okay. Part D, is it possible that the proportion of all adults who would travel to outer space in their lifetime if given the chance is more than 50%? Sure, it's possible. Anything is possible, right? It's not likely, though. So from our calculation in Part C, we are 92% sure that if we had surveyed all adults in the world and asked them this question, only between 39.98% and 46.26% would say that they would do this. So more than 50% is very unlikely to happen. If we're 92% sure that it'd be between these two numbers.